So this is a video that's going to go through oxidation and reduction questions. There's a worksheet that I am doing and it is available on my website. If you want to try it first, there's a link to the website in the description. So the very first one is identifying oxidation numbers, particular compounds with or particular atoms within a compound. So to do that, you do want to remember that oxygen is always -2 unless it's a part of a peroxide, and hydrogen is always +1 unless it's directly bonded to a metal, then it's -1. So if we're looking at this and it's just asking for sulfur, we do kind of have to assign the rest. So oxygen's always -2. So with 4 atoms, that's a total of 8. Hydrogen's always +1, with a total of 2 atoms, that's +2. Should have said -8. So sulfur in this case, because there's only one of them, would have to be +6. So if add all this up, it would equal 0. So in this first one, it is going to be, because it's just asking for sulfur, +6. If I look at the second one, SO2, again, oxygen's always -2, but there's 2 of them, so -4. So to have this compound add to 0, sulfur would have to be +4 to add to 0. So this one is +4. Our last one in this section, Na2SO3. Let's assign oxygen, -2. There's 3 of them, so that's a total of -6. And then sodium, we know this is a simple ion, it's +1. We can just look at the charge on your periodic table. Again, there's 2 of them, so +2. So in this case, we would want our sulfur atom to be +4 so that this whole compound can add to 0. So that's the first little bit. Looking at the next one, this one's asking about nitrogen. Really the biggest change here is the one on oxygen, and that is showing that, or sorry, the one on B when we have an ion. So, but we're doing the same thing. I'll just do it over here again. NH3, let's assign hydrogen. It's always +1, and there's 3 of them, so that's +3. So nitrogen would have to be -3 to add to 0. So that first one's -3. Now this next one, NO3 negative, we now need our whole thing to add to -1 because our ion has a charge. So oxygen is still -2. There are 3 of them, so -6 in total. Nitrogen in this case would have to be +5 because we want our whole compound to add to -1. So then we have +5. And then that last one, N2O, again, oxygen is -2. This time there's only 1. We want to add to 0 because it's a neutral compound. So nitrogen would have to be +1 because there's 2 of them. That's a total of +2. And then we can add to 0. So that's a +1. We just can't tell. Now, the next one is looking at whether we are an oxidation or reduction within the substance. When I teach this in chemistry, I always say, just a reminder, when we're looking what's undergoing these, you always pick the reactants. Okay, products just help us see what's happening. You always pick reactants. So for instance, let's assign oxidation numbers. So an element by themselves is just 0. We know oxygen's -2. This case, copper would have to be, so to make this compound, just looking at ion charges, would have to be +2. So if you swap and drop, it would reduce to 1 and 1. So copper is +2. And then we would see that sulfur will be +6. On the right-hand side, your product side, copper by itself is 0. And then doing the same thing, zinc was +2, -2 for oxygen, and then sulfur +6. So we see that there's a change in zinc. It's going from 0 to +2. And so it is losing electrons. And if you're losing electrons, that's oxidation. So zinc is a substance being oxidized. Copper is going from +2 to 0. So that would be Rig, gaining electrons. And that substance would be that whole thing. So even though it's the copper that's changing, saying the substance, you write down the whole thing. So again, notice I am using my products to see what's happening, but whenever you're picking what's being oxidized and reduced, you have to choose a reactant. The next one, same idea. An element by himself is 0. MgO, O is always -2. Mg is going to be +2. So Mg is going to, I went too far, become positive. So that is losing electrons, so oxidation. Oxygen is going to become negative, so that is gaining electrons, so reduction. So when it's asking about oxygen, is it being oxidized or reduced? In this case, it is being reduced, and we can tell based on oxidation numbers that you are gaining electrons because of the gain of electrons. Now, if you're finding this helpful so far, please subscribe. And just to point out one more time that I do have a website. I hope you'll check it out. And there is a whole section, this is just a snapshot of it, showing where you can find that worksheet in the electrochemistry section. And I will have this video posted up shortly. If you're watching it, it's posted. So number 5, going over the same idea, you have a half reaction. We have Fe2 positive turning into Fe3 positive. So your oxidation number is just the charge number. So we could see here that you are losing electrons, right? Because you're becoming more positive. We also see that we do have an electron on the right-hand side, which shows that loss. So this is oxidation because you are getting more positive, you're losing electrons. Okay, so going to oxidation and reducing agents. If you're an oxidizing agent, you are undergoing reduction. If you're a reducing agent, you're undergoing oxidation. So we are doing the same thing and same idea. We always pick reactants. Products just help us see what's happening. So chlorine is going from 0 over here to -1. Potassium on this side, so we'd have -1 here, +1, and this is staying as +1, and iodine is going to 0. So we assign our numbers, we see that change in chlorine going from 0 to -1. Hopefully that, I feel like gaining electrons is usually more obvious. So that's undergoing reduction. So if you're undergoing reduction, you are an oxidizing agent. Then iodine is going from -1 to 0. So that means you are losing electrons. And if you're losing electrons, you are a reducing agent. So here the Ki is undergoing oxidation, and it's your reducing agent. A similar question, figuring out your agents. So anything by itself is 0. Oxygen is always -2. With that, we can figure out iron and aluminum. So here we have a total of negative. So this has to be +3. And here, same idea, +3. So aluminum is going from 0 to +3. That is a loss of electrons. And if you're losing electrons, you're undergoing oxidation, and that makes you a reducing agent. And iron is going from +3 to 0. So that had to gain, had to gain electrons to neutralize those positives. And if you're undergoing reduction, you are an oxidizing agent. So just write down that whole compound. Again, to emphasize, pick reactants, not products. It's your reactants that are actually reacting, and those are your agents. Oxidation numbers. So again, we've been doing that, but just keep going. Assign your numbers, and then take a look at what's happening. So -1, +1. So oxidation number of Na before the reaction, it is 0 because it's an element by itself. And after the reaction, it becomes +1. Chlorine was 0 and then becomes -1. So what's being oxidized is, if you're undergoing oxidation, you're losing electrons. So that would be the chlorine gas. And what's being reduced, if you're being reduced, you are gaining electrons. Sodium is getting more negative, so it's gaining. And again, we're picking reactants. The next one, similar idea. Copper by itself is 0, iron by itself is 0. We know oxygen is always -2. And with that, we can figure out the rest. So +4. So going through this, before the reaction, iron was +3. After, it is 0. Carbon was 0. And after, it was +4. So going through those same questions, what's being oxidized? So if you're oxidizing, you're losing electrons. So iron is going from +3 to 0. So that is reduction. I said that backwards. So that's being reduced, the iron in the first compound. And then carbon is going from 0 to +4. So that is undergoing oxidation. Because you're getting positive, you're losing electrons. So the carbon by itself. Okay. So lastly, explain how oxidation and reduction are involved in resting of iron. So if iron is being reduced, or oxidized, sorry, let's just take a look for a second. It is reacting with oxygen to form Fe2O3, I believe is the iron or the rust formula. So if that's the case, you would assign your numbers, and this would be +3. So we see oxygen going from 0 to -2, so that is gaining of electrons. So for oxygen, it is being reduced, and your iron would then be oxidized. So the oxidation of iron is it being exposed to oxygen to make it go from 0 to +3. So that is our quick little worksheet. I hope you found it helpful. If you did, again, please subscribe. And again, please check out my website. The link is in the description. This is just the electrochem section, but there's one on thermochem, there's one on organic chem, and one on equilibrium acids and bases. If there's any other video you would ever like me to do, just leave me a comment. And as always, thanks for watching.